Hi children, in today's class, let's take up the relationship between the sides of a right triangle. This is probably one of the greatest discoveries in the history of mathematics. When a triangle has a right angle and if squares are made on each of the three sides, then the biggest square has the same area as the other squares put together. Here, the longest side or the side opposite to the right angle is called as the hypotenuse. So, Pythagoras stated that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other two sides. In short, it's written as a square plus b square equal to c square. Here, we should not view this as an algebraic equation because Pythagoras did not view it in that way. He viewed it as a geometric statement about areas. With the rise of modern algebra, it has assumed its algebraic form. This is how Pythagoras proved this theorem. He used a technique called proof by rearrangement. He took four right triangles and placed on four corners. Then he placed two right angles next to each other. Here, in both the cases, the area of the outer square has not changed. The area of the four right triangles has also not changed. So, the remaining areas must also be the same. So, the area of the biggest square will be equal to the areas of the smaller squares added together. Now, let's pass on to an interesting debate. We know that trigonometry is the base for architecture, astronomy, space exploration, and a lot more things. We also know that right triangle is the base for trigonometry. So, if without a right triangle, no architecture is possible, then how pyramids were built hundreds of years before Pythagoras actually discovered it? Also, if it was already existing before, then why is it called as Pythagoras theorem? Let us time travel backwards and try to explore the truth. Almost all the civilizations in the world, starting from Babylonia, Egypt, India, China, had the knowledge of right triangles many years before the birth of Pythagoras. These are the images of Plimpton 322 from Babylonia. Babylonia was often affected by floods, and once floods were over, the surveyors had to measure the land once again. Here, they are said to have used these right triangles. They considered triangles as the diagonal half of a rectangle. Now, let's move on to Egypt, where we have the pyramids. The ring papyrus, which was found in the excavations, contains 84 to 86 puzzles, out of which one deals with calculating the slope of the pyramid, that is the hypotenuse. Also, they used 3 knots, 4 knots and 5 knots in a rope, which would guarantee a perfect right triangle. They used it to get perfect angled corners in their pyramids. We find the use of right triangles in these 2 countries, but we do not find any statement or proof of the theorem in these 2 countries. The first explicit statement of the theorem was given by Baudhayana from India, who lived 300 years before Pythagoras. He said that when a rope is stretched along the diagonal, it produces an area which the vertical and horizontal sides produce together. Baudhayana was a priest and an architect of very high standards. He skilled himself in the practical use of mathematics. This theorem is found in the Sulb Sutras given by him, which are the rules for the construction of altars. He also states that if A and B are the 2 sides and C is the diagonal such that A is divisible by 4, then we can calculate the hypotenuse easily using this formula. Here is the comparison between Baudhayana and Pythagoras. How close is it? There is a Tamil version of this rule which runs as follows. It means that divide A by 8 parts and subtract 1 part from it. If you add half of the height, you will get the hypotenuse. The simplicity in the theorem is really amazing. Though Baudhayana stated the theorem and used it, he did not attempt to prove it. The Chinese book called Zhu Bin Xuanjing, which has a collection of 246 puzzles, has the Gogu theorem, which is the Chinese version of the Pythagoras theorem. It was written by a mathematician called Shangao. Though some claim that the proof is more of an algorithm, but the steps of the algorithm is similar to the proof itself. Pythagoras is by tradition credited as the first mathematician to prove that theorem, and there are 367 proofs for the same theorem, and the number is still increasing. So, we can conclude that the Babylonians and the Egyptians had an idea about it, while the Indians gave it a complete statement and the Chinese proved it. So, Pythagoras can be associated with this theorem for taking this theorem to his country and popularizing it. Now, let's return back to the world of pizzas. Which one is profitable? One large pizza or two medium pizzas with a given diameter? Did Pythagoras influence your decision? Look at this. If you cut the pizzas in half and place them on the sides of a triangle, you can compare the areas and come to a conclusion. Not only squares or semicircles, Pythagoras' theorem is true for all regular polygons. Here are some of the uses of the theorem in today's world. We know that Pythagoras' theorem works only in right angle triangles. Only in a right angle triangle, a square plus b square will be equal to c square. But we can also conclude that if it is less, then it will be an acute angle triangle, and if it is greater, then it will be an obtuse angle triangle. Thank you, children.